Hello guys, this is the short screencast to take you through your Term 1 experiment for Year 9 Science. Now this experiment and assessment piece built on what you learnt in Grade 8 last year, which is how to design fair tests. So essentially you're going to be designing a fair test after you build an electric water heater. Essentially we used to call them kettles. So this little design here is essentially exactly the same as an old-fashioned kettle, electric kettle. It was made of nichrome wire, and when you connected the nichrome wire to a power outlet, ran electricity through it, the resistance in the wire would change or convert the energy into a lot of heat, and you'd end up boiling the water. That's the original electric kettle, and that's what you're going to be building. But once you've built it, you're going to actually pick a variable, one variable that you think is going to improve the efficiency of how quickly that wire boils the water. So you're aiming to find one variable that you can change to see if it either slows down or speeds up how quickly the water heats up. Now the variables could be quite a few choices there. We'll go into them in a little bit more detail, but the base test that you're going to be running is you have to heat up 80 ml of water, and each test has to be 10 minutes long. Now that's important to remember, because if you stuff it up and have to start again, you have to start that whole 10 minutes again. So please make sure that you know what you're doing before you pull out any equipment. So step 1 and step 2 are essentially getting into groups and coming out and filling out a planning document. Now each one of you needs to do this separately, because you'll be submitting it separately. So although you're going to be filling it out together and helping each other out, each of you actually has to have your own copy. And in that document you're going to be identifying the variables for your test, your dependent variable, your control variables, and also your independent variable, the one thing you're going to change to see if it affects how quickly the water heats up. You're then going to move on and set out your aim, your research question, and your hypothesis, as well as draw up a basic plan for how you're going to put all of the components together. And all of that has to be handed in before you touch any equipment. So what are you going to need, and what are you going to be planning out for? So essentially you're going to be given all of these components. We've got this nichrome wire here, and you'll notice they've got a coil there. You've got your alligator clips and your wire, and you're joining onto a battery pack. Now whatever you do, don't turn that on unless the nichrome wire is actually in water. It does heat up an awful lot, so if the heat can't go into the water, it's going to heat up the wire quite a bit, and it could even end up melting the wire. So please make sure that you only turn it on when the wire is in the water. So you're going to be placing your wire in a beaker like this, just a 250 ml one. I might change color there, a 250 ml one that you get out of our cupboard, and you're going to be putting into that a set amount of water, because remember it said in your beaker you're to have 80 ml of water, okay, and then into that you're going to then add put in your nichrome wire over the top, and it's just got to sit in the water like that and then be joined up to your battery, okay? And that's the base setup for your electric kettle. Now let's think of a few of the things that are going to affect, or might affect, how quickly it heats. You could just try and change your power pack, but on your instructions it actually says to leave that at 8 volts. So you could move it if you want, or you could leave it at 8 volts for maximum efficiency. Me, I'd rather test some of the other things to do with the wire rather than the power pack. Another thing you could do is you've got 3 different types of wire. Now if you want, you could actually test each one of those different types. The difference between them is the thickness. So you've got 3 different thicknesses, I should say, of wire, and you could actually test if the thickness has an effect. You could also think about how long it is, okay? Because remember, this is a resistor, So the longer the electricity has to push through that resistor, the nichrome wire, the more energy it might actually expend or transform. So that might be something you have a look at instead. There are other different factors that you could think of as well. Like I don't want to give them all out to you, but I do know that in your kits, I think they're also giving you salt. And there's something you might remember about salt water and electricity, and if you wanted to test salt and its effect on heating water, you could try that. And any other variables you can think of, give it a go, and you have to pick one of these things to change and test, and of course the rest have to be controlled. Okay, that's really, really important. They have to be controlled. So let's go through the steps. Number one, you're going to collect your printed planning sheet, printed from me, once you've got your groups. And each student has to have their own copy, and you're going to be filling that out by hand. And it's going to take you through initially, you might even be able to see it in there, your dependent variable, your independent variable, might be able to highlight them there, and what we call the independent variable groups. It actually explains that to you again. So independent variable is what you change. So if you zoom in here, my example says my independent variable is, say, a type of fertilizer. Great. But then what groups do I have that of the types of fertilizer? Well, I could have cells, I could have polymers, I could have black and gold. Each one of them are my independent variable groups. Okay, so it's going to take you through the steps of planning that experiment so that you identify all the variables ready to do the next step. Once you've done those variables, you're going to write out your aim, your research question, and your hypothesis. And the instructions for that or scaffolding are again on that sheet. Next, you're going to make a list of the safety precautions that you're going to be following while you do your experiment. Okay, again on that sheet. And once you've done all of these, you can upload them to Gateway, a screenshot of it, so it can be approved and ticked off. And if I'm able to see it and check it off pretty much straight away, then you'll be able to go and get started on your water heater. Step 2, you're going to be setting up your equipment, and before you actually do any tests, it's actually best to actually set it up and see how this actually works and how it all fits together, and identify any control variables. When you're setting up equipment, you actually identify an awful lot of control variables better than you do when you're just talking about it. Now, I will note here, I'll zoom in a bit here, that this design is really awkward. See how you've got the alligator clips, I'm going to change my color there, those alligator clips sitting on the side of a beaker there, okay, and you can't hold them with your hands while it's working. They're often very precarious if you don't set them up in the right manner. So you're going to have to make sure that you arrange the clips and the wires and the cords in a way that's going to allow that coil there to stay in the water during the entire experiment, preferably without you having to hold it there the entire time. So as you set up your equipment, you're going to also have to give a thought as to how you're going to organize it properly so that everything fits and everything is set up nice and neatly, and you can actually let it run for 10 minutes without having to hold everything in place. Once you've set them up, you're going to take a photo of your setup, because I'd like you to upload that later. Okay? Next thing I have is I want you to draw your version of that diagram. So you need to draw on your sheet how you are setting up your equipment. Now I've made a little bit of a error here because I thought I put down there 100 ml of water. It's not 100, it's 80. But I want you to draw out all of the equipment, the beaker, the water, the wires, the alligator clips, the battery pack, everything, and it all must be labeled as well. Okay, and you need to draw that in and present that ready for submission. Okay, now while you're doing that, you can also make notes on how you're going to control things and keep them the same. So if, say, let's think, I'm just thinking here, if we were changing the voltage, okay, if that's what we were changing, then everything else would have to be the same. So every time we started out, we'd have to make sure that we had exactly the same amount of, say, water, and we'd have to make sure that we had our wire and stuff exactly the same setup in all of the different trials. Like, how are you going to make sure that exactly the same amount of wire is in the water each time? All of that sort of stuff needs to be thought about, and while you're setting it up is a great time for you to make notes on measurements or set rules that you're going to have to control your variables, i.e. in this case, always measure out 80 ml of water. Okay, so that's a measurement that is used to set out a control variable. We don't just say a small amount of water, we say 80 ml of water. Okay,